All right, we're about to dive into some of the most incredible technology on the entire planet. But here's the twist. It didn't come from some fancy lab or a Silicon Valley garage. Nope. Its origins are way, way older and a lot more surprising. Let's get right into it.
So let me just pose a question here, something to really think about. What if all the best, most game-changing inventions we've ever come up with
weren't actually invented by us? What if we just discovered them, copied them from a blueprint that's been in the works for, just a few billion years?
There's actually a name for this whole idea. It's called biomimicry, and it is a seriously powerful concept. It's all about looking at nature as like the biggest, oldest research and development lab in the entire world. I mean, we're talking almost 4 billion years of trial and error.
Okay, so for our first stop, we're literally diving in. We're going deep underwater to check out how the ocean's biggest creatures are helping us solve some of our trickiest engineering problems. So let's start with wind power. You know those giant turbines, right? Well, one of the big challenges is that the blades can get inefficient and super noisy. But get this, the humpback whale figured this out a long, long time ago. If you look at the front edge of its flipper, it's not smooth at all. It's got these weird bumps on it. They're called tubercles, and they help it turn on a dime in the water.
And this is biomimicry at its best. Engineers basically said, hey, let's try that. They added those same kinds of bumps to turbine blades. And what happened? The turbines got quieter, and they started capturing way more energy. It's such a simple fix, and we have the humpback whale to thank for it. Okay, here's another one for you. How do you make something move through water with less drag, and at the same time stop stuff like bacteria from sticking to it, all without using nasty chemicals? Well, for that answer, you gotta look at one of the ocean's most famous predators. The whole secret is in its skin. It's covered in these tiny little grooved scales. And the ways we've used this idea are just wild. We're talking coatings for giant ship hulls that stop barnacles in their tracks, saving a ton of money on fuel. We're talking about surfaces in hospitals that naturally resist bacteria, which is huge for preventing infections. And, yeah, you guessed it, super fast swimsuits. In fact, one of these swimsuit designs was so ridiculously good, so fast, that it was actually banned from international competition. Seriously, that's how you know you found a good design, right? When it's so perfect that we humans have to make it illegal in our own sports? All right, let's move on to another really tough problem. Picture this. You need to get inside a collapsed building, or maybe explore a deep-sea volcanic vent, or, even worse, inspect a damaged nuclear reactor. It's way too dangerous for a person, and a normal, clunky robot would just get stuck. So, who do you turn to for inspiration?
You look to the absolute master of escape and infiltration, the octopus. I mean, think about it. No bones. It can squish its body down to fit through any little crack that's big enough for its beak. It's just the ultimate get-anywhere creature.
And that idea gave birth to this amazing field called soft robotics. These are robots made from flexible, squishy materials, just like an octopus. They can wiggle their way through tight spaces and cluttered areas without breaking anything or getting trapped. They're basically our go-to tool for exploring places we just can't.
Okay, so we've been talking about these massive ocean creatures. Now we're going to flip the script entirely. Let's scale things way, way down and look at the insect world. Because it turns out, some of the tiniest engineers have the absolute biggest ideas. So here's the puzzle. How can you build a really tiny robot that's also super strong? The answer is probably in your backyard. Just look at an ant. That little thing can lift stuff that's way, way heavier than it is. It's all about how they use leverage and have these incredibly sticky feet. So, some engineers at Stanford basically copied the ant's whole deal and built these little micro-tug robots. These things weigh next to nothing, but they can pull something more than 2,000 times their own weight. To put that in perspective, that's like a person dragging a blue whale. It's just mind-blowing.
Okay, let's switch gears and talk about light. First up, capturing it. That's the whole game with solar panels, right? You want to grab as much sunlight as possible. So how do you make a solar panel that's better at soaking up light?
Well, you look at a butterfly. Turns out the super dark black parts of a butterfly's wings have these tiny, tiny structures that are amazing at trapping light and not letting it bounce off. So we're copying that pattern to make better, more efficient solar panels. But what about the flip side? Not just capturing light, but making it. You know, the LEDs that are in pretty much everything now, our phones, our TVs. How do you make those brighter without using more power? For that one, they looked at the firefly.
If you look really closely at a firefly's little lantern, it has this rough, jagged surface. That texture actually helps more of its light get out. So by putting a similar pattern on top of an LED, we can make it shine brighter using the exact same amount of energy. So clever.
All right, for our last section here, let's look at some stuff that's so common, you probably use it every day without even realizing it's a copy of something from nature.
Think about a bat. It can fly around in pitch black darkness and never hit a thing. How? It sends out these little sound waves and then listens for the echoes bouncing back. It's called echolocation, and it basically lets them see with sound. And you know what? We've copied that exact idea.
You know when a doctor does an ultrasound to see a baby? That's just man-made echolocation. Those parking sensors in your car that start beeping like crazy when you get too close to something? Yep, that's echolocation too. Even the fancy systems that let self-driving cars see the road, it all comes from studying how a bat does it.
So after all of this, whales, sharks, ants, bats, what's the big takeaway here? What's the point of it all?
I think the point is this: the greatest designer on the planet is nature itself. It's already solved so many of the problems we're still wrestling with. The next huge breakthrough, whether it's in medicine or robotics, it might not come from a lab. It might just be out there, waiting for us to notice. The real question is, are we paying enough attention